Welcome back. Today we are going to move with part 2 of current electricity, where we shall discuss the color code of carbon resistors. You know, resistors are essential components to divide current across various elements in any electronic gadgets. So, it is very important to know the value of resistance before assembling a particular component of a gadget. So, the resistance value is not being printed in resistors because it will create lot of inconveniences. As the resistance get dirt, some or few digits may be vanishing. That will result in wrong calculation and wrong result in assembling a component. So, to indicate resistance, the resistors are given usually few colored rings around them. Each color is associated with a value or a digit, and arranging them in a proper manner, we can calculate the total resistance, the minimum possible value that can be obtained from it, the maximum possible value, or the limit of that resistor component. In our NCERT syllabus, our discussion is confined to resistors marked with 4 colored rings. But actually, there may be even 5 or more colored rings. Now, let us see what we have to know from those colored rings. I will show you a practical resistor with colored rings drawn around it. Let us see that. Now, you can see a resistor in my hand with 4 colored rings. The first one, this is green. Second one, blue. Third one, red. And the fourth and final one is gold. I repeat, green, blue, red, and gold. Let us see one more resistor. Here in this second resistor, you can see the first 3 rings. All are red. And the fourth one is again gold. So, in the initial resistor, you have seen the color sequence where green, blue, red, gold. Here it is red, red, red and gold. Now let us go into its detailed calculations. The first 3 colors give resistance. Each color, as I said earlier, is associated with a digit. Arranging them in a proper way, we can get resistance in ohms from the first 3 colors. The fourth color gives its tolerance, and tolerance is expressed in percentage. By calculating the resistance and by knowing the tolerance range, we can calculate the minimum possible value obtainable, also the maximum possible value that can be obtained from the given resistor. Now let us think of what digits are associated with the first 3 colors. Now, the digits associated with first 3 colors, those 3 colors may be any 3 among these 9 colors. Black is with a 0 value, brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, grey 8 and finally white 9. But at least for few kids, it is difficult to memorize this color sequence and the associated digits. To solve that, we have a meaningful sentence. You can remember it very well. And by analyzing each word, of course, it is easy to remember. By analyzing each word, you can easily find the digit associated with each color. Let us see that sentence now. In electronics, grid means a perforated electrode, means an electrode with the holes. Bias means the voltage supplied. So grid bias means the voltage on that perforated electrode. So unless you select correct resistor, the voltage on that grid may go wrong. This is being written in this sentence. This is a meaningful sentence. Buy better resistor, or your grid bias virtually goes wrong. Just to see the letters written in black ink at the beginning of each word. By the starting letter is B, and this B is given the value 0, which is black 0. Now better, that also starts with the letter B. It is taken for brown as 1. Now R of resistor, its value is 2. Now O stands for orange with digit 3. Y for yellow, value 4. Capital G from the word grid stands for green, 5. B from bias stands for blue, 6. Virtually, from that we have the first letter V stands for violet as 7. Gray, that means the ash colored ring, it is assigned value 8. And finally, W from the last word, that is white, 9. Buy better resistor, or your grid bias virtually goes wrong. Now, there are certain alphabets, certain letters that repeats. The first one is B. First B for black, second B for brown, the third B is for blue. Similarly, the letter G repeats. First G for green, second G for gray. So again, remember this sentence. Buy better resistor, or your grid bias virtually goes wrong. So you can easily memorize the digits assigned with each color. Now from this, how can we calculate the resistance from the colored rings marked on a resistor? Let us see. Now, the first resistor I have shown to you in the beginning is this. It's marked with 4 rings. First one green, second blue, third one red. And fourth one is not a matter of discussion now, at least, because as I said earlier, it gives tolerance. After this section, we will discuss that. So green, from the sentence that we have now, green, what is the value of green? Buy better resistor, or your grid. The G from grid, that is the 6th word but value or digit associated with it is 5. Whenever you reach a particular number as far as the word in the sentence is concerned, you just deduct 1, because starting word is not with value 1, it starts with 0. So I reach the 6th word, subtracting 1 from it, the value of green becomes 5. So green 5. And blue, again think of the same sentence. Buy better resistor or your grey bias. The 7th word is blue. Naturally, 7 minus 1, 6 is its digit. And as far as red is concerned, buy better resistor or the 3rd word. Now naturally its digit is 2. Now resistance is given by first color digit, in front of it second color digit, and the 3rd color is made as power of 10 and multiplied. So 3rd digit is the multiplier digit. Make it power of 10 and multiply with the value that you obtained from the earlier 2 colors. First color value, second color value multiplied by 10 raised to 3rd color. So the resistance here, it is first color value 5, second color value 6 into 3rd color value is red with 2. So it is 5600 or 5600 ohms. This is to calculate the resistance. First color value, second color value, then 10 raised to 3rd color value. This gives us the resistance. Now, for tolerance, there are 3 cases. One is gold. It means plus or minus 5%. That means the resistance highest value will be 5600 ohm plus 5% of this value. Its lowest value will be 5600 ohm minus 5% of this value. Now, if the 4th color is silver, it indicates plus or minus 10%. And finally, sometimes a resistor may have only 3 colored rings. That means 4th color is absent. So that case can be regarded as 4th color, no color. If it is no colored, it is plus or minus 20%. So, the first 3 colors give resistance. Last ring, its presence or absence indicates tolerance. If the 4th color is golden, it is 5% tolerance. 5% may be added and can be subtracted to obtain the limiting range of that resistor. If the 4th color is silver one, it indicates plus or minus 10%. And if the 4th color is absent, it means of high tolerance plus or minus 20%. This is how to calculate resistance and tolerance. Now let us think of the examination point of view now. Let us see an examination question. A carbon resistor of 2.7K is to be marked under 10% tolerance. Give the color code. So the value is 2.7K. Don't get confused by that usage. K represents their kilo ohm. Had it been M, it would be mega ohm. Now, given resistance is equal to 2.7K, means 2.7 into 1000 ohm. 2.7K means 2.7 kilo ohm. 1 kilo ohm is equal to 1000 ohm. It will be, remove the decimal. When we cancel decimal, 1 0 will vanish. The remaining is 27 into 10 raised to 2 ohm. Eliminated the decimal by multiplying with 10. Now the resistance left behind is 27 into 10 raised to 2 ohm. From color code values, we know 2 is red, 7 is violet, again 2 is red. Now, what did they say about tolerance? They demanded 10% tolerance. We know the fourth ring that indicates tolerance, had it been gold, plus or minus 5%. If there were no color as the fourth ring, it would be 20%, but 10% is with the silver color. So red, violet, red, silver. This is the color sequence, and this must be the answer to this question. So sometimes they may mention the color. All the four rings will be specified in the question. We have to calculate resistance and tolerance. Some question may be asking maximum possible resistance. Then we will calculate the resistance first. We will calculate its concerned tolerance in percentage. We will add that tolerance percentage value to the calculated resistance to get maximum value. And we will subtract from the calculated resistance the tolerance percentage. Then we will get the minimum value. Sometimes the question, they may give the resistance value. We have to select the colored rings. Now, this is about color code with 4 colored rings. As I said in the beginning, our syllabus is confined with this discussion. And some of you might have developed a doubt by this time. If instead of 4 colors, what would happen if 5 colors are given? The values are again same, but calculating the resistance in case of 4 colored rings, we have done it in this manner. First color digit, second color digit, and multiplied with 10 raised to third color digit. Now if there are 5 rings, we will write first digit, second color digit, third color digit, and the multiplier will become that of fourth color. That's only the difference. First color, second color, third color, and the multiplying value will be 10 raised to fourth color. And the fifth color will give you the tolerance. So that will also not going to puzzle you. Okay, I will give detailed color charts as far as resistance color code is concerned. I will give you some simple question, application type and skill type. I think by this discussion, you will be able to solve the questions based on color coding of resistors. I hope you enjoyed the class. You may make it useful in your ensuing examinations. This much from me for the day. Please share, like, comment and subscribe. Till we meet next, it's bye from me. Take care. Bye.